projects. In this video, we are going to explain about the project, which is text mining and emotion classification on Monkeypox Twitter dataset, a deep learning natural language processing approach. Introduction of the project. The recent outbreak of the monkeypox virus has underscored the critical need to understand how the public perceives and responds to diseases. This project aims to delve into the public sentiment surrounding the monkeypox outbreak, recognizing the heightened anxiety it caused globally. The World Health Organization declared it a public health emergency, emphasizing the urgency of studying public reactions. With the prevalent use of social media and the abundance of online news articles, vast amount of text data can be generated for analysis. The project leverages the technique of emotion classification to analyze text data, particularly from social media platforms, providing valuable insights into people's emotions and attitudes towards the monkeypox outbreak. Emotion classification, a technique commonly employed in psychology, marketing, and political science, plays a pivotal role in this project. By categorizing text data into emotional categories using deep learning algorithms, project aims to identify areas of concern and emotional distress during the monkeypox outbreak. This information is crucial for developing targeted approaches and effective communication strategies for addressing disease outbreaks. The project distinguishes between discrete emotions. Discrete emotions involve fundamental emotions like fear, joy, or surprise. The project employs various natural language processing techniques to extract and pre-process the monkeypox dataset. Emotion classification is carried out using NRC lexicon to categorize text data into 11 emotional categories. Deep learning algorithms including LSTM, CNN with LSTM, and BiLSTM are utilized for model development. Coming to the objective of the project, the primary objective is to analyze and understand the diverse range of emotions expressed by individuals on social media in response to the monkeypox outbreak. This includes capturing sentiments, concerns, and opinions related to the disease. The project aims to provide real-time insights into public sentiment regarding monkeypox. By identifying critical concerns expressed in social media posts, the goal is to enhance the awareness and understanding of the disease on a broader scale. Employing NRC lexicon, the project objective is to predict and measure the emotional significance of each text in the dataset. This step contributes to the nuanced understanding of the emotional tone associated with discussions about the monkeypox. The project focuses on developing and comparing deep learning models including CNN, LSTM, BiLSTM, and CLSTM, which is CNN with LSTM for emotional classification. The objective aims to find the most effective model for accurately categorizing emotions within the context of monkeypox related social media content. The objective is to enhance the model's performance. The project aims to address class imbalance in training the dataset using technique which is SMORT and random undersampling. The objective ensures a more robust and unbiased training process, improving the model's ability to generalize and accurately classify emotions. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this initial step, necessary Python libraries and packages are imported into the project environment. We imported pandas for data manipulation, NumPy for numerical operations, Matplotlib and Seaborn for visualization, TensorFlow and Keras for deep learning, Flask for web development. Coming to exploring the dataset related to monkeypox tweets is loaded and explored to understand its structure, features, and contents. This step is crucial for gaining insights into the data before proceeding with any analysis. Visualization. Visualizations are created to provide a graphical representation of the dataset. This step helps identifying patterns, trends, and outliers in the data, contributing to a better understanding of the information it contains. In data processing, emotions in the text are detected using NRC lexicon, a Python library for emotion analysis. Any URLs or unwanted characters are removed to clean the text. Punctuation marks are removed to ensure uniformity in the text. Common stop words like and the E's are removed to focus on meaningful words. The text data is normalized, potentially involving tasks like stemming and lemmatization. Tokenization. We have used Keras tokenizer, which is applied to convert the processed text data into numerical tokens. This step prepares the data for input into the machine learning models. The next step is feature selection and smooth sampling. In this step, relevant features are selected and smooth, which is synthetic minority oversampling technique, is employed to address class imbalance in the dataset. This is crucial for training robust machine learning models. Splitting the data into train and test. The dataset is split into training and testing sets to evaluate the model performance. This separation ensures that model's effectiveness can be assessed on unseen data. Building the model. In this step, deep learning models architectures are defined in this step. It involves specifying layers, nodes, and activation functions of the model. Training the model. The model is trained on the training data using the specified features and labels. This step involves adjusting the model's weights based on training data to make accurate predictions. Flask framework with SQLite for sign up and sign in. Flask framework, which is a web framework, is implemented with an SQLite database to handle user authentication. It allows users to sign up and sign into the application. User gives input. Here, users provide input, which is text or the information relevant to monkeypox. Pre-processing the given input. The user input is pre-processed, following the same steps as in the data processing phase to ensure compatibility with the trained model. Trained model is used for prediction. The pre-processed input is fed into the trained machine learning model to predict the outcomes. The next step is LDA model for topic modeling. Latent dirichlet allocation, which is LDA, is applied for topic modeling. It helps identifying underlying topics in the text data, contributing to a more comprehensive understanding of the information. Final outcome is displayed to frontend. The results of the predictions and the topic modeling are displayed on the frontend for the application, providing users with insights based on their input and the model's analysis. Algorithms which are used in the project are BiLSTM, which is bidirectional long short-term memory. It is a type of recurrent neural network architecture, which is RNN architecture, specifically an extension of LSTM. It processes sequences bidirectionally, incorporating information from both past and future time steps. This is achieved by using two separate hidden states, one for processing the sequence from the beginning to the end, and the another for processing it in reverse. BiLSTM is effective for capturing long-term dependencies in the sequential data, making it suitable for analyzing text data, such as social media posts. In the project, it is used to understand the temporal aspect of emotions expressed in monkeypox-related tweets. The next algorithm is LSTM, which is long short-term memory. It is a type of RNN designed to address the vanishing gradient problem in traditional RNNs. It can capture long-term dependencies in a sequential data by maintaining a cell state, selectively updating information through gates, which is input forget output gates. LSTM is suitable for processing sequences of the data, making it valuable for analyzing text. Its ability to retain and selectively update information over long sequences makes it useful for understanding the emotional context expressed in monkeypox related tweets. The next algorithm is CNN with LSTM, which is convolutional neural network with long short term memory. It combines the strengths of convolutional neural network in spatial feature extraction and LSTMs in sequential learning. CNNs are used to capture spatial patterns, and the output is fed into the LSTM for sequential modeling. It is beneficial when both spatial and temporal features are essential. In the context of the project, it is applied to extract meaningful patterns from the textual content, which is CNN, and understand the temporal aspect of emotional expressions using LSTM in monkeypox related tweets. Coming to CNN, which is convolutional neural network, it is a deep learning architecture widely used for image recognition. It employs convolutional layers to detect spatial patterns in the input data, making it suitable for tasks involving grid-like data such as images or, in this case, text related as 1D sequence. While primarily designed for image processing, CNNs can also be adapted for text analysis. In the project, CNN is applied to capture spatial patterns and the meaningful features in the textual data, enhancing the understanding of the emotional expressions in monkeypox related tweets. As an extension, we applied an hybrid model combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built the front end using Flash framework for user testing with the user authentication. We have used accuracy, precision, recall, and F1 score, which are the performance metrics, to evaluate this project. So here we have the performance comparison graphs for all the models built in the project. This is accuracy comparison graph where x-axis represents accuracy score for each algorithm and y-axis represents algorithm names. Similarly, we will have for other graphs also. Accuracy is the measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is the recall score comparison graph. Recall is also known as sensitivity or true positive rate. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains the algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign up file. This file is the database file used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. And now we need to type the command python space app.py and then click on enter. This command will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. This is the localhost and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so we'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First, we need to click on that. And here we need to enter all the registration details if we are signing up newly. I have already signed up and I have an account in it, so we will directly click on sign. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a text box where we need to give the input message. Input message here is a public tweet related to monkeypox disease. After giving the message, we need to click on predict. Then we will get the prediction that tweet belongs to which type of sentiment. So here I'm giving the message. Now we will click on predict. Here we got the prediction as the tweet type is positive. Application has predicted that this particular message belongs to the positive sentiment and the topic for the paragraph is most dependent upon these words. Here from the prediction and the message we can understand that people are positive about monkeypox disease. Now we will give the other message. Click on home. I have given the message. Now click on predict. Here we got the prediction as the tweet type is anger, which means this particular message belongs to the anger sentiment and the topic for the paragraph is most dependent upon these words. Now we will give the other message. Click on home. I gave the message here. Click on predict. Here we got the prediction as the tweet type is disgusted, which means this particular message belongs to disgusted sentiment and the topic for the paragraph is most dependent upon these words. From the prediction and the message, we can understand that people are disgusted about the monkeypox disease. Now click on home. We will give the other message. I entered the message here. Click on predict. Here we got the prediction as the tweet type is trust, which means it is trust sentiment and the topic for the paragraph is most dependent upon these words. Now we will give the other message. Click on home. I entered the message. Click on predict. Here we got the prediction as the tweet type is no emotion, which means this particular message has no emotion and the topic for the paragraph is most dependent upon these words. Now click on sign out. In this way, if we enter the public tweets related to the monkeypox to the system, then the system will detect which type of sentiment do the tweet belongs to. Conclusion of the project. The project concludes that leveraging emotion classification on social media during the monkeypox outbreak provides valuable insights into public sentiment. This understanding is crucial for public health officials to gauge the emotional impact of the disease and tailor communication strategies accordingly. Through the exploration of various deep learning algorithms such as LSTM, BiLSTM, CNN, and CNN with LSTM, the project identifies the effectiveness of these models in classifying emotions. This highlights the robustness of deep learning in extracting emotional nuances from the textual data related to disease outbreaks. The classification of the emotions into discrete and dimensional categories offers a nuanced perspective on psychological states of the individual during the monkeypox outbreak. This information serves as a foundation for developing targeted psychological support programs and interventions for those affected. The project underscores the importance of natural language processing techniques, including tokenization and pre-processing, in extracting meaningful information from the large text datasets. This enhances the overall data processing pipeline, contributing to the success of the emotion classification task. Beyond emotional classification, the integration of the FLAS framework for user integration, along with the application of latent dirichlet allocation for the topic modeling, enhances the project's comprehensiveness. These components provide a more holistic understanding of the monkeypox related discussions, extending the project's value beyond emotional analysis alone.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.